Geometry 2-6 algebraic proof. All right, so we're dipping our toes. We're getting into proofs, and we did a little bit of geometric stuff in 2-5, and now 2-6 we're looking at algebraic proof. And again, there's so much writing that I'm not going to fill up this whole video writing. I'm just going to talk through the notes, and you pause and write down as you need to. All right, so we're gonna just draw this big old chart and fill it all in with all of this important information. And this is stuff that we have looked at in algebra. So hopefully this is kind of review. So there are, I recommend just drawing a line across and then drawing a line down and then just filling this in and drawing lines across instead of counting how many you need and doing that kind of stuff. So let's talk through each of these properties. Addition, property of equality. If A equals B, then A plus C equals B plus C. What I'm saying is, what I do to one side, adding C, I do to the other side, adding C, and that makes this still be equal. These two expressions are still equal if I do the same thing to both sides. That's the addition property of equality. Subtraction of property of equality is the same thing, but I'm talking about subtracting something from each side. Multiplication property of equality, same as addition, except for instead of adding or subtracting here, I'm multiplying. What I do to one side, I do to the other. Guess what comes next? Division. So, same thing. If I divide C from both sides, then my equal sign is still good. What I do to one side, I do to the other, and my equal sign is still happy. Reflexive property. All right, so this one might be a little bit new. Reflexive property just means that one thing, whatever it is, equals that same thing. So 5 equals 5, 12 equals 12, whatever. The length of this pencil equals the length of this pencil. That's what the reflexive property says. And you will use this in proofs. Symmetric property of equality. If A equals B, then B equals A. So you can just switch things from whatever side of the equal sign to the other, and we're all good. Transitive property of equality. So this one is very much like the law of syllogism that we just learned about in 2-5. If A equals B and B equals C, then A equals C. So if A equals B, B equals C, then A equals C. This is the transitive property of equality, and you will see that again and again. Substitution property, look, and I have all of this here to look at, of equality. If A equals B, then A may be replaced by B. So here's an example. Okay, A equals B. I know that. If A plus 4 equals 6, then B plus 4 equals 6, because B and A are equal. So I can just substitute B or A in this equation, and we're all good. All right, let's keep moving here. Distributive property. If A times B plus C in parentheses here, if we have this expression, then we can set that equal to A times B plus A times C. That's the distributive property that we've learned eons ago. All right, and that is the end of the chart. So here are all of the properties that you're going to need to know for this lesson today, besides ones that maybe you've learned before. So now let's do a 2-column proof. We're going to do a 2-column proof. We just learned how to do those in 2-5. And we're going to prove that if negative 5 times x plus 4 equals 70, then x equals 18. So we're going to prove that. We're going to prove that x equals 18 if this statement here, I'll make this equal sign a little bit clearer, equals. If this statement is true, then this statement is true. So let's do some work here. So here's my statements and here's my reasons. So the first thing I'm going to write down here in my statements is my given statement. -5 times x plus 4 equals 70. So I'm going to put that in my statement, and that's the given. And now I'm going to do some work here to in order to prove that x equals -18. So my first deal, the first thing I'm going to do is I'm going to distribute -5. So I'm going to use my distributive property here. So there it is. I've multiplied -5 by x, and I've multiplied -5 by 4 and got -20. So -5x minus 20 equals 70. And I used the distributive property. Notice how I didn't write distributive property out. I just did dist prop, and that's fine. We don't need to write all of the words out all of the time. Okay, now I'm going to add 20 to each side. What I do to one side, I do to the other. And if I add something to each side, I'm using the addition property of equality. So, addition property of equality plus prop of equal sign. So, so I added 20 to both sides, so the 20 goes away, and then I've got 70 plus 20 is 90. -5x equals 90. And so the step that I took to get there, addition property of equality. Now I'm going to divide by -5. So I divide each side by -5, and then if I look back up here, I use the division property of equality. If I do divide something by one side, I've got to divide the other side by that same thing. I divided by -5, and so that became x, and that became -18. Division property of equality, and that is my that is what I was trying to prove, that x equals -18. So now I have done my I have completed my 2-column proof, proving that if -5 times x plus 4 equals 70, then x equals -18. Whew. All right. Okay, you're going to do a U-try. Would be cool if we were in class. Then I would have you guys take turns on this one on the board. Each person would take a step, and I'd call you, and it'd be super fun. But we don't get to do that today, so here we are online. So you're going to go ahead and prove this. You're going to do a 2-column proof, set it up just like the one above, statements and reasons, put the given, put the reasons, and that is how you're going to do this. Go ahead and pause and tackle this thing. Okay, so let's see how you did here. Let's do 2-column proof, statements, and reasons, and hopefully I have enough space on this piece of paper. If not, I can just add another one on the bottom. So, statements. The first statement I make is the given. 2x minus 13 equals -5. And I want to get to x equals 4. The reason for this is the given. This is what I've been given. And so I want to get x by itself, so I'm going to add 13 to each side. And so I end up with 2x equals -5 plus 13. That gives me positive 8. And what I did there was I used my addition property of equality. What I added to one side, I also added to the other side. Now I'm going to divide both sides by 2, and that is going to get me x equals 4 by the division property of equality. What I divided by one side, I divided by the other side, and so I have the division property of equality, got me from this step to this step, and I have done my proof. All right, we got some more, another chart to draw out. All right, now we're going to look at doing a geometric proof, and we're going to talk about property and the segments and the angles version of that property. So, and this one is, you can just see the whole chart here. So I'll just leave it all up and you can draw it as you would like to, and then I'm going to explain it. So the reflexive property in segments says, okay, if I have segment AB, then that equals segment AB. Remember reflexive earlier where A equals A? Measure of angle 1 equals measure of angle 1. So reflexive just means that the thing equals itself. Symmetric. If AB equals CD, then CD equals AB, right? So if symmetric, we can just flip it across the equal sign. Same thing with this, with angles. Measure of angle 1 equals measure of angle 2, then measure of angle 2 equals measure of angle 1. Okay. Transitive. Remember I told you this is going to keep coming back. Transitive. If AB equals CD and CD equals EF, then AB equals EF. If measure of angle 1 equals measure of angle 2 and angle 2 equals angle 3, then measure of angle 1 equals measure of angle 3. That's the transitive property. Let's do a proof. All right. If measure of if angle FGJ is congruent to, which is the same as, right, angle JGK, and JGK is congruent to angle KGH, then x equals 6. Okay, so here is the diagram that we're given here. So it kind of looks like an X, but it's not quite an X. Or maybe it is actually an X. Yeah, okay. So FGJ is congruent to, so this angle is congruent to JGK. So this angle and this angle are congruent. And JGK is congruent to KGH. So these two angles are congruent and these two angles are congruent. So we need to prove then that x equals 6. So let's figure out how we might do that. So we start with our big table here, our 2-column proof. Statements on the left, reasons on the right. The first thing we write in our statements is the given. Look, this last time I got lazy and I didn't write all of this out for the given. And, you know, you should write it all out. There are teachers that would dock you if you didn't. I'm not super concerned about it, but it is helpful to write everything out. And my reason for this statement here is the given. All right. So the first thing I'm going to do is I know that this angle and this angle are congruent, and this angle and this angle are congruent. I want to say that these two angles are congruent. And they are because of the transitive property. So I'm going to say FGJ is congruent to KGH by the transitive property. Then, since these are equal, or these are congruent, then their measures are equal. And so now I can say 6 plus 7 equals 8x minus 5. Is that what I did next? Yep. And I did that by the substitution property of equality. So what I did was I substituted 6 plus 7 as my angle measure for FGJ. And I substituted 8x minus 5 for my angle measure of KGH. So these are equal, or these are congruent. And there is a step that we could take in between here, but we're not going to. So I took the measure of this angle and put it right here, and the measure of this angle and put it right here. And so I just substituted those values into here. And so substitution property of equality. Now I'm going to just solve this algebraically. So I'm going to probably add 5 to each side. Oh, no, I subtracted 6x from each side. So if I subtract 6x from each side, then I end up with the 6x goes away. I end up with 2x here 7 equals 2x minus 5, and I used the subtraction property of equality. And then I'm going to add 5 to each side to get this 2x by itself. So I added 5 to each side, which is the addition property of equality. And so I end up with 12 equals 2x. Then I'm going to divide by 2 from both sides to get x. And I would use the division property of equality. X equals 6, which is exactly what I wanted to find. X equals 6. And I switch those across the equal sign so the x is on the left and the 6 is on the right, just like I was supposed to prove up here. And that is the symmetric property of equality. That's what I used to switch those across the equal sign. And that is 2-6 of geometry. Good luck on the homework.